problem with our instructor Kalyan, so he should be back in a couple of minutes. So thanks for your patience. Kanta Reddy, can you hear me? Can you say something, Kanta Reddy, so that I can check with me if something is wrong with my system or not?
Good morning.
Yeah, can you hear me?
Yeah, I hear your voice.
Okay, good. I can hear you. So that means that Kalyan is having some issues. So let's see, he's coming back. Okay.
Okay.
Yeah. Okay, Kalyan, I have made you a panelist again. Yeah.
Hello, Krishna. Can you hear me?
Yeah, I can hear you. Can you?
Yes. Now I can
Okay.
hear. I actually had to just disconnect and reconnect, and now it's working.
Okay, fine. So can I make you the presenter and we can get started? Yeah.
Yes. Certainly. We can start off. That's not a problem.
Okay, great. Okay, so you have to click show my screen.
Okay.
Great. We can see your screen.
Okay.
And we are on, Kalyan. Okay, go ahead. And I will be, yeah, go ahead.
Okay. Good afternoon, everybody, and welcome to this session on the introductory webinar for remote laboratories. To begin with, the objective in the introductory webinar, we are going to look into several aspects of what remote labs are, how they are going to be useful, how it has already been useful, and how could one build a remote lab? What are the steps? Just a small top level steps involved in how one could build a remote lab. And we will also look at how some students in the past have done a few remote labs as well. So I think that would be the overall discussion. Firstly, the acknowledgements. This workshop is presented by IUCE, supported by IOE in association with Electronic Solutions. This is the Team RL. I think we have got good support from student teams as well, who have built remote labs and are continuing to do so. So I believe that the student teams who are present for this one will also benefit from this kind of technological development. The motivation behind looking at remote labs from the Indian academic institutions perspective is something from this few images you can get a hang of it. Krishna, at any point of time, if you want to jump in, please do. I'm just continuing.
No problem. I'll do that. Thanks.
Yeah. Okay. Right. So the motivation has been that we all know that there is whatever infrastructure, laboratory infrastructure that is present in academic institutions are utilized for a certain period of time when the lab hours are there, and rest of the time it's pretty much idle, like what you can see. So the objective is to enhance learning. We know that laboratories are important, and to ensure that these laboratories are utilized effectively for learning and learning purposes, there should be a way in which you can engage the laboratories for longer duration of time, and remote labs can kind of facilitate that kind of a mechanism. In addition to getting the laboratories online, there is another major infrastructure, which is all the software tools that are involved. There's a huge bunch of software tools which is available, and these software tools also many a times are installed in specific computers and are not accessible to remotely or otherwise. Many a times they are not even uniform in installations. So it would be very, very important to ensure that the software tools that are there could also come on a common platform and being remotely accessible. In this way, you can have a huge infrastructure, which is the software tools that are available and the hardware physical laboratories that are available in the institution to be remotely accessible to students. And the idea is to build the technological platform to facilitate such a mechanism. So typically, what we would be trying to mention is that remote labs and its possibility to enhance learning, research opportunities, introduction to what cloud-based technologies in remote labs are. We will look at, hopefully, we'll look at some demos. So the possibility of having a enhanced learning environment with a remote lab is from how learning happens in human beings. There is this very famous Sanskrit saying where Acharya Padama Datte Padam Shishya Swamedaya Sabrahmacharibhya Padam Padam Kalakramena Cha. So learning happens in various ways, as you know, a part of it from the teacher, apart from their own thought processes, apart from discussing with peers, and apart with respect to time, where experimentation is a big player, which plays a big role, which is the fourth element, which is learning with respect to time. So the experimentation environment, as you can see, physical experimentation becomes very important. So there are two technological aspects in building remote labs. One for the software infrastructure, where you have a facility to establish software which is remotely accessible. And second one is for a physical laboratory infrastructure. There are two elements basically. In the software infrastructure space, where you want to enable a software to be remotely accessible, just a software tool, there are certain aspects to how you can enable a cloud infrastructure for that. How do you set up a cloud infrastructure? How do you install these tools in the cloud infrastructure? How can many users access these tools simultaneously, with their own personal interfaces, personal storage spaces, and how you can recall your previously done work, and with some analysis. So this is one element of the software based laboratories. On the other side, on the physical laboratory, it's not necessarily any one particular branch of engineering. For all branches of engineering, every single physical laboratories can be potentially remotely enabled, can become a remote lab. So the steps involved, typically, I'm sure you will have a lot of questions when I say this, because there will be a lot of questions related to how it is possible when there is a lot of human intervention involved. How is it possible to load and unload objects? How is it possible? What are the security constraints? What are the access constraints? How do you detect if something goes bad? So I fully understand that you're going to have a whole lot of questions in this direction, and that's the purpose, or that's the objective why we are talking about building your own remote labs, because you will actually walk through the path and face these challenges, understand each one of them as to what is, what are the challenges involved, what are the complexities, why something works the way it works and why it doesn't, and so on and so forth. So how does these things help? I mean, we already have some bit of analytics here. We've done some bit of implementation tests that are done to show that yes, remotely accessible systems are going to be useful, and it's going to enhance certain level of learning and access to technology. So that's some preliminary statistics that are there on your screen right now. How will it help engineering institutions per se and the students is, from the engineering institutions point of view, especially from the faculty members point of view, it is a single point for centralized maintenance. So I understand that many a times the laboratories have individual faculty members as the mentor for the laboratory, or they are pretty much responsible to maintain those laboratories. So this is going to help you, help centralize your system maintenance and many other aspects of your laboratory infrastructure. More importantly, it will help you track utilization parameters, primarily from the perspective of learning. What is often said is that if somebody is able to actually repeatedly use a particular infrastructure, then learning is bound to happen. I mean, that's pretty much how anyone who is conversant with any of the technologies today, whether it is as simple as a smartphone or the internet, Many a times it's not something where people are taught how to use it, but people end up using it just because you repeatedly use a given infrastructure repeatedly, and then learning tends to happen automatically. Similarly, if there is an opportunity for students to access any infrastructure, laboratory infrastructure repeatedly at their convenience, then it is bound to facilitate learning. Having said that, a remote lab is not a replacement to a conventional laboratory for sure. The objective is the conventional laboratory is very much the fundamental learning environment, and the remote laboratory, which could be an add-on to the fundamental laboratory. It doesn't mean that the remote laboratory is different and fundamental laboratory is different, nothing of that sort. It could be an integrated element wherein students come and perform their experiments in the laboratory classes on their regular schedules. And the only aspect, add-on aspect to this is the same laboratory in the same context, in the same infrastructural parameters are also available for students to access from remote locations as and when needed. So this is going to enable and enhance access, as we discussed. And in order to build this kind of an infrastructure, the interesting part is talking about the physical remote laboratories. In order to build your own remote laboratory of this nature, the kind of tools and technologies involved are pretty interesting and complex. It takes all the way from the fundamental sensor technology, IoT, actuator systems and technologies, electronic controllers and programmers, cloud infrastructure or cloud development, cloud environment development, application development for cloud infrastructure. You also have remote application development, and also you will have user interface design and development. So it kind of encompasses almost all the latest trends and technologies that one can think of, starting all the way from the physical level. Even from a mechanical laboratory or a civil laboratory point of view, every single laboratory that you can think of in all branches of engineering or chemical or whatsoever it is, you have an element of being able to learn the technology to enable it to have a remote access and remote monitoring and control. So with the current trends of industrial IoT, Industry 4.0, and many other latest trends and technologies in industrialization world, this becomes a very, very handy technological expertise that can be built in order to facilitate those kind of technologies that are upcoming. What you're seeing on screen is some such case studies. Just to throw light into one of them, this typically, if you look at any one of these systems, I mean, of course, you see different systems here. I'm just showing you one on the left side. What you're seeing here is a particular system where there are two tanks, and the water from the lower tank is required to be pumped to the upper tank, and then you control the level in the upper tank based on a certain condition. So how do you do that? You pump it. Now the pump that is going to be used is an electric pump. So you know how you can control the pumps. So if you know how to control the pump, you can actually control how much water can go there. You can have sensors which are detecting the level. You have actuators which are again turning on and off the valves. So pretty much everything is controlled by a digital controller, and then that digital controller is connected to the computer. So the computer has a software, and then through software you're able to monitor and control the entire infrastructure. So Krishna, if you want to jump in, then I would like to talk about research opportunities.
Okay, great. Let me jump in here again, and to all of you, there are about more than 20, 30 people, almost 30 people here. What I want to emphasize is that this is something very, very unique. I think it's very, very unique even for the colleges in the in the United States and other places to even be doing these kinds of things. And there are two things that I want to point out here. One is, as again, just at the risk of reiterating something that Kalyan already has mentioned, One is that it is not a replacement for an actual lab. We all know that that's something that that's very important. But what it allows students to do is to practice and practice and practice. And we all know that students learn best by trial and error and practicing and making some mistakes and so on. And so this kind of practice can be done online at nights in their homes, in their things. So that's the kind of amazing teaching opportunity, learning opportunity that this provides, and it's unique in the way that very few people in the world are doing these kinds of things. The second important thing that Kalyan also has pointed out is that building such a lab itself, building such a system for any one experiment, the team that does that, the students that do build such a remote lab, will acquire so much enormous amount of in-depth practical experience in all these various things like IoT and sensors and actuators and all these things. So it is really a project-based learning at a very high level for those who are building these remote labs. And as he will point out, there are some examples of students in the past few years that have worked with Kalyan who have actually become entrepreneurs because of the skills that they acquired and set up their own companies because of the skills they acquired in building such a remote lab. So I just want to emphasize those 2 points before Kalyan goes on. Go ahead, Kalyan.
Thank you, Krishna. So when we are talking about state-of-the-art technology infrastructure development, it is more than obvious that it has a lot of research opportunities. The very fact that the remote labs per se is new, not just in India, as Krishna pointed out. This is pretty much new all over the world. Even in the most developed parts of the world, remote labs are still in the making. So that gives a terrific advantage for anybody to publish research content, and there is without any doubt, I can also say that in addition to publishing research content, there is a huge scope for IP development and IP establishment, including patents. There is a strong possibility. That's again not because of just that it's being new, but the kind of technologies that this infrastructure, this technology platform infrastructure is going to touch upon, is going to open up new possibilities. So that is the reason why this is pretty much a very interesting thing to work on. A very, very famous quote from Peter Diamandis and Steven Kotler is about the impact of technology, the 6 Ds. It is pretty much obvious that whenever a technological framework is going to get created, it follows a certain curve, and this is what the curve talks about, which is digitization, a digitized infrastructure followed by a deceptive environment, a disruptive, dematerialized, demonetized, and democratized. So the whole idea or the whole consideration here is that if something gets digitized, there is a huge disruptive technology that can evolve out of a digitized environment. Whether information transfer that happened in the earlier decades, where availability of information got digitized, led to such huge disruptive access to information. Similarly, it's pretty obvious that if laboratory infrastructure gets digitized, the whole idea of establishing a remote laboratory also means that you're actually digitizing the whole infrastructure. Whatever is the physical infrastructure that we are referring to is going to get completely digitized. So obviously, when it gets completely digitized, there's going to be a tremendous disruptive technological enhancements and opportunities. Whenever there is a newly digitized product, this is all about a few historical stories as to how a physical world, when it has become digitized, has led to a huge revolution. We all know the famous story of Kodak, which actually was the founder of the digital camera way back in 1975. But for various reasons, Kodak is history today just because they didn't catch up with the digitized technologies. So it is pretty much the case with any of the information technology related aspects, where something that gets digitized is actually going to be very, very disruptive. So that is the reason why entrepreneurship or or even job creation and job development becomes very, very obvious, and it is the technological shift in the job in the job description that becomes more important, and that's where I believe the students should be prepared for the future. And I believe this experience of building remote labs of this nature will actually facilitate those transition points and can actually put students one step ahead. So the research element, the research opportunity per se, because the whole technology platform is pretty much new, the research opportunities are plenty, starting all the way from the physical layers of integration of sensors, actuators, in a way where it's going to be completely remotely enabled. Maintenance systems, there's a huge issue related to maintaining systems remotely. So there's a huge opportunity for research on maintaining the remote systems. I wouldn't be surprised to see a new job opportunities coming up called as remote systems engineer or a remote systems manager. This I believe with Industry 4.0 taking pace, catching up speed, these kind of new jobs could be more obvious in the near future. So a lot of remote engineering based opportunities are going to come up extensively in the near future. And I think a little bit of understanding of how these remote labs works could actually facilitate a huge tectonic shift in this direction. As mentioned, the technologies used include cloud solutions, big data analysis, digital solutions and automation, networking, sensing and signal conditioning, embedded programming, system engineering and design, and cyber physical systems. So, people who are involved in designing and developing and building remote labs on their own will more or less touch upon all these technological aspects that we are talking about. I mean, that has been put up in front of you right now. So more with the kind of resource limited nation such as ours, I think this is going to be more important and much more obvious that such an infrastructure is obviously necessary. The scope and need is pretty much how you see on the screen, with the internet percolating at all levels in India, with the internet speeds in India being almost at par in the world today. I mean, that's the reason why we are all, on the same platform sitting and having this webinar. That itself shows that, how well internet is percolated and how well it is accessible and how we are connected, and how this kind of a platform can now help facilitate the next level of interconnections and technological enhancements such as remote laboratories. So I think it's very exciting to see how many systems can actually become remotely manageable. How many systems, industrial infrastructure, office infrastructure, system-related infrastructure, production infrastructure. I think pretty much every infrastructure would necessarily have some level of remote monitoring and remote maintenance and remote control and remote production management systems and so on. So that's pretty much the scope. And at this stage, I thought.
Let me jump in again for a second. Okay. Yeah. I'm going to jump in again and again, re-emphasize again the unique opportunity that we have in India, because we have Kalyan and his team to lead the world in these kinds of changes. And it is not just changing the way students access labs in your courses, but it's really, as Kalyan mentioned, it's a whole new profession which will go throughout industry, is remote engineering. So when I graduated in 1967, many of the professions today that exist for many students were not even existing. And so you can see that in the future, there'll be new professions like remote engineering and so on. And this is kind of the technology that at the cusp of which that we are talking about today will drive those kinds of new professions. And so you who are in academia, will be able to train your students with practical experience, and which will also help them, some of them become entrepreneurs and in this new area. So I want to take a quick poll. I want to get a sense of how many of you are students, faculty, or others. So if you can just have a little patience with me, I'm going to launch a poll here right now. I'm going to select this particular quick poll that I made up. I'm going to launch it. I just want to get a sense of how many of you are faculty, student, and other. Just take a few seconds to respond, please. I'm just going to wait for some more time. We've got about half of you have responded. I just want to see how many. Okay. Okay, keep coming, please. I need a few more. This is what we're going to do while we are taking the course and stuff. We will have interaction. Even though this technology is remote, we are able to do some interaction through these kinds of polls and get some ideas. Many of you have not voted. Can you please jump in and please respond? You can respond very easily. This is technology. Use the technology. If you're going to build a remote lab, you need to be able to use this technology and respond using technology. Okay, I'm going to close right now just to give us a sense of what the approximate numbers are. So most of the participants are faculty, about 80%, and about 10% are students, and another 10% are industry. I recognize one of them, Anil Pandit, who is a retired engineer from GE. So thank you, Anil, for joining us. I need your kind of inputs and so on. I'm going to hide that and let's go back to you. Okay, you're back, Kalyan.
Yeah, thanks, Krishna. Oh, nice to know that Anil was here. Hello, Anil. How are you doing? I didn't realize that you were there. Okay, that's nice. Just to show a case of how you can access a remote infrastructure, starting with the software. What you can see on my screen is one Cloud Software Central that has been designed and developed for a particular case.
Let me just interrupt you for just a second, because I think sometimes the technology is a bit of has a little glitch here. I'm going to make sign you out for a bit and as a presenter and bring you back. Okay, just hang on a minute. Okay, just bear with me just a second, and I'm going to make you plan. Okay, so I just click show my screen again, because sometimes what happens when I do a poll, some type of technology does not get back on track. We're on track now. Go ahead.
Yeah. Okay, great. So like what Krishna mentioned, there are a few strong research opportunities, and as I mentioned as well, the one thing that I can tell you is that as of today, there doesn't exist even an IEEE standards for remote labs. And the fact of the matter is we are involved in designing these IEEE standards for remote labs. We are a part of this process called IEEE 1876 that is being designed. I'm a part of the drafting committee. So we are working on building IEEE standards for remote labs. So that's the kind of opportunity that we have as we keep working on these technologies. I'm pretty confident that we can really contribute in a big way from here in India through IUCE and other opportunities to kind of make a mark on a global platform by really contributing to designing IEEE standards for remote labs. Just a heads up on that. So in order to launch, you can remotely access a given set of tools or software that you have, and what you are seeing right now is just a small demonstration of a case study where you can actually by a click of a button, you can launch a complete software platform from your remote location. And the best part is this particular system or this particular access is primarily from the perspective that the particular tool that we are talking about is not installed in your local system. It is installed in the cloud infrastructure. It is installed in the cloud server. And then you can connect to it from your remote location, and you can use it. And during this process, your system would not be, your system resources would not be utilized, and it's pretty much where all other system resources would be from the centralized cloud infrastructure. So you've got the additional element to this is obviously there is a mechanism in which you can book slots, or you can schedule in such a way where different users can access the tool in a different location. What I'm showing you is a kind of a booking mechanism just to ensure that each user have their own access to the tool in their personalized login credentials and login environments. And you then launch it with a access. So now what you're seeing is one particular case of, this particular case is of LabVIEW. So I've just dragged and dropped a few things just for you to have a look at. So this particular, infrastructure is remotely accessible. I can pretty much drag and drop the devices. And then the best part is I'm also launching multi-SIM simultaneously. So I can put other set of devices, I can run them simultaneously, I can connect them simultaneously, so on and so forth. So the idea is that you can pretty much have multiple tools running at the same time without consuming your local system resources and being able to access these tools from a remote location. So this is one of the aspect of having software remote lab, and then from the perspective of a physical remote lab, I would also get into how you could access a physical remote lab as a demonstration. But before I get into that, talking about the software remote labs, the benefit or the possibility is that most of the tools can be put under your software library, just like how you have libraries, digital library as well, where you've got your pretty much a lot of books in a digital form, where students can access this digital library. In a similar fashion, we could have a software library which is in the cloud, and students can access, obviously whoever is authorized can access these tools from wherever they are, and be able to perform their set of experiments, operations, and whatever it is. And the more interesting part is being able to facilitate a co-simulation. Now, I understand that co-simulation is kind of picking up as a technological requirement, wherein there are going to be multiple tools. We all know that each software tool has its own specific applications, and they invariably tend to generate a certain set of outputs and results based on certain inputs. And then there are many other tools which might be required to take it to a logical conclusion. So more than one tool would be involved in developing an end-to-end solution. So in such a scenario, what typically is anticipated of, especially in mathematical modeling and design of systems, whatever be the field of engineering it is, when we are talking about mathematical modeling of systems, which is catching up at a very rapid pace in current environment, what happens is you might need more than one tool, more than one, two, or three tools to actually develop a complete end-to-end solution. And in that context, it is very, very difficult, or pretty much non-practical, to have all those three tools installed in your local computer and expect to run co-simulation, because it really requires high levels of computation capability, RAM capability, and a lot of system resources, which normally on a general computing platform such as personal devices or personal laptops or desktop computers would be lacking. So with the cloud infrastructure having high-end computational capability and systems, you can actually achieve pretty much all of those, or most of those. So the next mechanism that we could try to catch up with is on the digital remotely accessible labs, which I would try to show you. And in this labs, what we are talking about is a physical laboratory that I'm going to talk about is of 2-3 nature. So we have electrical or mechanical systems, whatever it is, we could try and catch up from that perspective.
By the way, what Kalyan is showing you is a BITS Pilani lab that he and his team have helped build. So BITS Pilani already has invested significant resources and paid and got Kalyan to build this remote lab at BITS Pilani, which he's actually accessing right now live from wherever he is in Bangalore.
As my colleague is connecting to the system, I think I'll just okay. Okay, so this is a fully remotely accessible lab wherein you've got several options out here. I'll be showing one of them. You've got, starting with something as simple as a rectification, something, I'm just showing you an example, to slightly advanced and higher complex systems such as an electrical motor generator setup. I would be showing you several such possibilities. So what you're seeing here is a simple full bridge rectifier system, wherein what you are seeing down here, you should notice one thing here, that what I'm connected to right now is actually something that is located in Europe. Okay, this is in Czechoslovakia. This is our partner organization. We are working globally with several institutions in building different types of remote labs, and we work with them in a very close, we are partnered organizations. So this particular setup, what you are seeing, is in Czech Republic. You can also look at this organization here, and you can notice that I'm able to control this device live. As you can see, the LED, the selection LED happening. You can see the LED picking up, wherein we are connecting a 10 microfarad capacitor into your rectification process. Now just notice this. Look at this graph right now. If the capacitor is removed, you're having a half-wave rectification done, right? So this is a half-wave rectifier, by the way. I can also select the full-wave rectifier here. So now you can see the full-wave rectification that is being done. And now I'm selecting a particular value of capacitance. I understand that you might have several questions as to, can I change the value of the capacitor, or is it going to be a fixed set of capacitors? In this particular case, it is a fixed set of capacitors. But if you all know that if you can design a variable capacitor, programmable capacitors, then you can make things better. So as I told you, that is the kind of opportunity for research and development and enhancement of the existing systems that is available, because there's a huge scope of improvement. So I add another capacitor, you're getting pretty much a fully rectified DC output. So
I just want to butt in here, Kalyan, and tell the audience that what an amazing thing that they are seeing right now. And you're saying this is somewhere in Switzerland. Where is it located? Austria?
This is in Czech Republic.
So this camera that's in Czechoslovakia, you're actually seeing the actual hardware. It's not a virtual lab. Keep in mind, what we're talking about are not virtual imaginary labs. These are real laboratories, real hardware that's out there in Czechoslovakia, and Kalyan is manipulating, changing the settings on that real hardware sitting right there in Czechoslovakia, and seeing the outputs in terms of the results of that experiment that he's trying to do on real hardware. So nothing virtual about this. And so that's the amazing thing. This is state-of-the-art, cutting-edge global engineering, education, and research. Okay, just go ahead.
Yeah. So going to the next, example. We have, this is because it is a hardware infrastructure. We understand that there has to be a certain level of, booking and certain credentials, because while one of them is operating the system, obviously, the other student might not be able to connect at the same time. So that's because of the nature of hardware infrastructure. And there's a huge scope of opportunity here to ensure that we can come up with ways and means of enhancing these limitations as well. This is the current situation of the infrastructure. So as you can see on this screen right now, what you're connected to is a physical laboratory of BITS Pilani remotely connected. You've got a asynchronous motor and DC generator coupled here. On the right side of the screen, you can see the live camera feed. This is pretty much the motor generator setup. What you see, the box in the front is a load box. Basically, that is the one which is the load that is for the generator. And you have the experimentation environment. I'll just take one small example. As you could notice, as soon as we connected to the system, initially, I don't know if you've noticed or not, but initially the camera feed was monochrome. And after launching this, it became color. The reason is pretty much, that all the lights were turned off in this particular lab. And when you connect remotely and launch it, the lights turn on automatically and then it becomes color. Otherwise, you know that these cameras are fundamentally monochrome, right? And only when there is sufficient illumination, they turn to color. Otherwise, in the dark, they show it as IR infrared, so it's monochrome, just for your information. So as you can see, I click the run button and then you can see the green light blinking, which says that the system is healthy, ready for operation. And I give a command, a control command, and you can see the speed picking up. The motor is running there right now. Look at this. The eyes are pretty much up. You're able to see it. Imagine a situation if you're also able to hear the sound from the motors. I think that's important, isn't it? And that should be the next progression, where you can stick in a mic out there and actually hear the rotational noise of the motors, and that would be wonderful, isn't it? And then taking to the next level, how nice would it be? Imagine a situation if we could have a virtual reality goggles or virtual reality infrastructure, if you can couple it with this, and with gesture control and with the virtual reality infrastructure, if you can augment it with the physical device and you just move your hands in a way to rotate the knob, and then the knob actually gets rotated and then you have the speed increasing.
This is like space technology. Wow, this is amazing. I'm just so fascinated. I can't resist jumping in and say, wow, this is an actual laboratory in BITS Pilani in Rajasthan, which you're seeing live, and you're actually able to touch and actually control the actual things. And as you said, wow, if I could hear the motors whizzing away, it'd be even more exciting. And maybe some of these kids that we are working with today will help you, make that happen. Well, this is just fascinating, amazing.
Yeah.
Good job, and I'm just so proud of you and you guys that made this possible. Go ahead.
Thanks, Krishna. Thanks so much. So with this kind of an infrastructural enhancement and development, what I can envision as the next step in this direction is something like this: that you've got a huge problem in a lot of industrial applications. I'm working very closely with Honda right now. We are looking at a complete Industry 4.0 installation at Honda. And especially at the plant near Bangalore, which is the world's largest two-wheeler manufacturing plant. They make 2.4 million two-wheelers per year, and that's the kind of capacity they have. So obviously, the number of machines that they would be having, and the biggest nightmare for the maintenance team out there in Honda here is that if one induction motor fails, they have about 2,000 odd induction motors running in different machines. And if one induction motor fails or anything goes wrong with one induction motor, the whole infrastructure trips. Okay, there's an electric trip that happens in their utility center. And it's impossible for the maintenance team to figure out what was the root cause for the trip and which motor among all the 2,000 motors has actually caused the trip. They spend 2.5 to 3 hours trying to debug and figure out and zero down on the exact induction motor that has caused the problem. And more often than not, the problems are pretty much due to leakage currents, which is something that you see once and you don't see the next time. So they simply go and turn on the circuit breaker. It starts working again, and there is no clue like why it got tripped and how it got tripped. Absolutely no clue. I'm just giving you one very practical case where working on a remote lab of this nature, I'm talking exactly the same case, asynchronous motor. That's what you're seeing there. working on a technology of this nature, being able to capture the data from the remote location. If you're able to do this for all the 2000 motors, first you can pick the motor which has was the reason for the tripping instantaneously. You don't really have to spend 2 to 3 hours to figure that out. That's point number one. Point number two, you can go on and predict that, 2 months down the line, or a month down the line, or 3 months down the line, these motors are expected to fail. You can get into predictive analysis and maintenance. Three, you know exactly what each machine's health is at any given point of time. What is the status of the machines, what each one of the machines are doing, and how they are performing, what is their throughput, what is their output, what is their efficiency, what are the skill metrics, plenty of them. So a technology of this nature, I mean, this is what I'm trying to see, how the development in an academic lab is going to result in an application in an industrial environment. I'm just trying to draw a 1:1 connect by establishing this kind of a requirement. Similarly, we are doing even in garment factory out there. They've got about 2,000, 3,000 odd, sewing machines. As you know, that each one of the machine, pretty much wherever there is movement that is involved, 90% of the cases involve induction motors as prime movers. I'm just giving you a small information. And imagine the future where in Germany, it's already been declared that by 2030, they really don't want to have ICE engine based, automobiles. So imagine the role of BLDCs and induction motors and these kind of, prime mover technologies, the direction how they are headed into, and imagine the kind of problems that you're going to face with them, and how remote monitoring, diagnosis, remotely, remote system health monitoring, automated system health monitoring, forecasting of failures is going to play such huge role in the coming future with respect to these technologies. So that is with respect to the demo. I mean, there are quite a few more remote laboratories, just for your information here. You've got, right now what you're seeing is one related to the motors. You've got one related to instrumentation and control. This is just an information that all this is, kind of possible. You can pretty much make any physical laboratory into a remote laboratory with a certain level of technological inclusion. It would be possible.
So let us now talk about the course, because we run out of time otherwise.
Yeah, I'm going to the course overview. That was the next thing. Yeah, the very next slide was course overview. So the course overview is going to be in 4 phases, where we are going to define the objectives, identify the scope of the remote lab, top level architecture with a basic block diagram, concept evaluation metrics, and a detailed block diagram. This is phase 1, wherein specifically the entire infrastructure for the architecture for the remote lab is going to be defined. In phase 2, the features of the remote lab will be frozen, and the capabilities of a particular remote lab will be defined, where we will end up defining what this remote lab is expected to deliver.
So I guess it's essentially, Kalyan, essentially what you're saying is that one team of a faculty member with about 3 students will identify the objectives. Now they'll decide, okay, this is what I'm going to do. This is the return. Now they can choose what they want to do and then work with you in each of these phases on that particular remote lab. Yeah.
Correct. Yeah. Thanks for adding that. So essentially, this is going to be a 20 to 22 hour kind of a course, wherein from the initial steps, it is about identifying what a remote lab architecture is, designing the architecture, developing the features and capabilities, designing for the system development, and then getting down to implementing the system, connecting it to a internet infrastructure, configuration of cloud infrastructure and development, software development, testing of this infrastructure at a component level and at the system level, system integration to ensure end-to-end connectivity, and cloud integration and testing. So these are pretty much how the phases are defined into, with the engineering design methodologies, the standard engineering design procedures being a part of this process by default. So what I would like to add now, Krishna, is
Yeah.
I think Vivek is there on the call, if I can see.
Okay,
So,
Vivek Gauripeddi. Vivek
yes,
Gauripeddi.
yes, that's right.
I'll make him the presenter.
Yeah, I think this is the remote lab by students, so that was done by Vivek. So if you could
Okay,
make
Vivek,
it the
you have
presenter.
to. I think you made your panelist. I think your mic will come in. Yeah, can you speak something?
Hello.
Yeah,
Yeah,
go ahead.
I'm audible.
Yeah.
Hello.
Yeah.
Hi, Krishna sir. Nice to get back to you again.
So,
And
so
hi,
you are a
Kalyan.
Yeah, go ahead, Vivek.
Yeah,
Tell us about yourself. Who are you? Tell us about yourself.
yeah, I'm in my final year of engineering in Dr. AIT Bangalore. So I've been involved with Kalyan and IOE for last 2 to 3 years. So we've been working on remote technologies, whatever Kalyan has been mentioning. And then this is one of the small projects that we've carried out last year. Okay, so this is basically a digital remote lab which cost few $100 to build, but then it was one of the most satisfying things that we did. I mean, because many people, have the perception that remote labs have to be expensive, they cost a lot, they need a lot of effort, all that. But then this is a small effort to show that anything as small as an Arduino or any small electronic component can be put together, and a remote lab can be built. So this is one of the mini projects that we did. And here you have a small microcontroller, and this remote lab basically verifies all your and or logic gates. So this is the projects we've built, and yeah, so that is it. This is the effort by us. So I think this effort has to be driven from faculty and student side. So my goal is that remote lab should be it should be built by the students for the students.
Oh, this is exciting. Fantastic.
Yes.
Yeah.
So
Vivek, your experience in publishing papers in this direction, anything would you like to touch upon?
yeah. So as recently as March, I've been to New York to present a paper on this digital remote labs, which was very well received by many academicians there. So it was one of the.
You went to New York? Did you say you went to New York?
Yes, sir. Yes, sir. I was in New York in March this year, 3 to 4 months back. So I was there for the 14th Rev conference, which is Rev is the annual conference of IAOE. So I think next year it will be in Germany. So I think we'll have a lot more participation from Indian contingent this time.
Which
so
college
yeah, it will all be at.
Vivek, which college?
It's called Dr. Ambedkar Institute of Technology, Bangalore.
Okay, very good.
So yeah, so I'm in my 4th year there. So yes, so yeah, we're all excited about the course and everything. So even I'll be helping out Kalyan with these things, and when we get started, I'll update you more.
Fantastic, great.
Yeah.
Thank you so much. It's exciting.
Thank you. Yeah, sir. Thank you, sir. Thank you so much.
Yeah. So yeah. So what appears to be the research opportunities and learning opportunities, having them on one side. The other side is the industrial application that I wanted to touch upon. As I already mentioned a little while ago, that it's pretty much Industry 4.0 compliant in all aspects. You're going to have things like production management systems, maintenance management systems. You're talking about overall equipment efficiency, skill metrics, effective throughput, machine health monitoring, machine status monitoring, asset monitoring and tracking. So it's going to be like a lot of applications around this, and I believe that there is a strong possibility to connect people who are involved in remote labs. I think we have an opportunity to connect them to the industry pretty quickly and directly. I think I would like to do that as well. As mentioned, one thing I would like to mention at this point of time, Vivek and team have already registered a company. They've started their own company.
Oh, wow.
Yeah, after doing the remote labs, because the kind of confidence and capability that they were able to build has enabled them to register a company, and they are offering services to us in many ways, to us directly, and they're having their own projects as well. They're doing some work they're supporting some parts of it for Honda for us, for the garment industry, K. Mohan. They're working with another important project with Bill and Melinda Gates Foundation for wastewater monitoring systems, remote monitoring systems of wastewater and sewage treatment plants. How effectively the water is being filtered.
Vivek, did I meet you when I came to Bangalore in July?
Yes, sir. I was there in the room. We had a discussion regarding.
Very good.
Okay, sir. See you again, sir, at ICTIU. Yeah.
Okay. Go ahead,
So
Kalyan. So you want to wind up? Yeah, go ahead.
yeah, I think so. The conclusion is like very excited to see how a lot of participation in this, and then see how we can build a huge Indian contingent with a lot of remote lab capability and development. I'm really excited to see that. And over to you, Krishna. That's pretty much what I.
Okay, a lot of exciting stuff here. I know it's we're coming to the end and not much time, but we're looking for questions. We'll extend our discussion for a few more minutes. So please send us your questions. While you're thinking of the questions, just realize the tremendous opportunity that we are making available through IUC and Kalyan to do some really cutting edge stuff. And I'm just going to put up the proposed schedule. He's already gone through the different phases, so I don't want to go through that. We will be starting this course in a couple of weeks, which is September 18th, and each session will be roughly 2 hours. As you can see, there's an enormous amount of hand-holding and detailed work that needs to be done, and therefore some of these dates, like October 2nd, somebody said is a holiday, so we might change that. But in general, this will be the schedule. And so we're looking for a few entrepreneurial faculty with the team of students to get this thing going from our side with the help of Kalyan. And as you can see, the opportunities are enormous. The students and faculty will get exposed to international opportunities for travel to conferences and so on, and show off their work and publish papers. And some students will become actual entrepreneurs, because this is such a new field that they can set up companies. So it's exciting opportunities that I believe you all should take advantage of. We are hoping to have maybe a handful of teams get started with this course. And so we're hoping that all of you who are here will jump right in with your and sign up for the course, and just send me an email or get into the link that we have been giving on where to sign up for the course. And in order to just make sure that we have to cover some basic expenses, and also to make sure that you're serious about being part of this course, we will charge you a very, very modest amount, which is really just 5,900 rupees for the whole team of one faculty member and 3 students, and we'll work with the team. And by the end of the course, I'm pretty sure that you will have built your first remote lab as a team. So what we're exploring right now is possibly, and again, we are open to any particular lab that you want to build remotely for your own situation. But in order to maybe make it a little more broad-based and effective, we're thinking maybe let us try to focus on maybe the second year circuits lab, where you have some fundamental foundational concepts are being taught to the students. And so the second year circuits lab, whatever experiments are done there, if you can make, if each one of the teams that joins this course builds 1 or 2 of those labs remotely, then by the end of the course, you might have about 5 or 10 of these labs available, different ones available for which then can actually be shared by each other across colleges, and that may be a good beginning. And I think the students who have taken that first semester, the second year first semester course in a lab, I know they realize the importance of the fundamentals that they learn in that particular lab, and many of them may have been frustrated that they really didn't learn as well as they could, because they could not really do the experiments live themselves, but they were just watching, and so this opportunity will improve. And so students who have been through that, and maybe who are in the second, third year or fourth year, would be possible members of the teams along with the faculty members. So sign up for this. Send me an email or just sign up on the survey site that I had set up for this course. So questions. I want to take questions, and let's see if we can get some response from. Let's see. I think there was an earlier question. There was about how is it possible for hardware laboratories, and I think you have answered that question quite well already through various things that you've demonstrated. More advantages. Anil Pandit, who was an electrical engineer who just retired recently from GE, points out that the more advantages of remote labs are multiple results. for incremental variables could be done at the same time using multiple remote labs. Okay, co-simulation can be done at the same time in different remote labs to establish the reliability. Third, telepresence for lab experiments through remote labs is being used for meetings in industry. So this is a validation from somebody who has been in industry for many years, one of our members of our industrial expert body that IUC has. So that's so let's see how I think we've kind of run out of time, and so maybe there aren't that many new questions. So this has been recorded. So I'm going to be posting this recording and sending it to participants who have registered for today's webinar and anybody else. So hopefully we have maybe excited a few people, faculty and students, to take the leadership role in doing this kind of work and signing up for our for our program. I'll wait for a couple of minutes in case somebody else has any other question that you want to ask. Kalyan, do you want to add anything more while we wait, looking around, seeing any other questions?
Another aspect to this is, like, in the process, if there is any entrepreneurial inclination, any set of students or faculty who is really interested to take up some bit of entrepreneurial effort, I think we would be more than willing to support. There is a lot of opportunity, as we know, so we would be more than excited to support entrepreneurial initiatives that comes out of this process.
Great. So I was in Bangalore, as I said earlier, this summer in July, and really exciting because Kalyan is surrounded by all these enthusiastic young students and recent students like Vivek, who are just building stuff and becoming entrepreneurs, and so they have experience in guiding entrepreneurial students towards small startup companies, and so that's another exciting part of what this project is all about. And you might find that by the end of this course, your team might actually have something that they can use to set up a little company. Discussions, and I think what we have done is we have I think the participants are in a state of shock that the exciting things that you have told us, and so there aren't too many questions. I'm sure they will follow up with questions by email. So feel free to do that. Email me or Kalyan, and I hope that several of you will register by the deadline of end of this week, September 10th. Is what we are, will be the deadline for registration for this particular course. And as I said, it's just a very, very nominal fee for one faculty member and 3 students, so just 5,900 rupees, which is really a great deal. We're not making any money out of this. We're just paying for some basic expenses by charging that fee. So please jump on board and be somebody who's a trailblazer in this field of engineering education, along with Kalyan. The international conference that Kalyan and Vivek were talking about is next year's in 2018.
Yeah, that's correct.
And we think we might have the 2009 in Bangalore, right? Is that? That's a distinct possibility. So it'll be exciting that if you start getting into these things, and then you'll get opportunities for international travel, publication, and recognition, and all kinds of good stuff. And faculty involved with it can use it for developing research and PhD programs. And
contribute to IEEE standards.
Yeah, absolutely. IEEE, as Kalyan has said, is just the beginning of this kind of activity with IEEE, and Kalyan is right on the leading edge of that. So let's join this movement and put India on the map in terms of remote labs for the world. Okay, and so Jai Ho. Thank you, Kalyan. Thank you, Vivek, and thank you, Anil, and thank you for all of you who have joined. And Jai Ho.
Thanks, Krishna. Thank you for everything. Wonderful. Excited to be there. Thank you. Bye.
Yeah, thank you so much. See ya. Bye-bye.
Yeah. Thanks, Vivek. Appreciate it. Thank you.
Yeah.